All right, so we're in the second part of chapter 8.5, and we're talking about applications of determinants. All right. So the first thing that we need to talk about today is we've been doing 3x3 determinants in our calculator. Well, there's one type of problem that we're going to talk about today that where we end up with a variable. We end up with variables in our determinant, and we can't use our calculator. And there were a couple of homework problems that we had where we had a variable and we couldn't use our calculator to do the determinant. So I want to show you how to find the determinant of a 3x3 matrix without using your calculator. It's not very complicated, and I think it's a little faster for a lot of matrices than using your calculator. So I'm just going to make up a matrix here. So here's my matrix. And I want to find the determinant of this matrix. So I'll write the determinant. You could write it either way. I didn't have to write the matrix first. So we're going to find the determinant of that. So what we're going to end up doing to find the determinant of this 3x3 matrix is find the determinant of three 2x2 matrices, which is easy. We all know. By now we should know how to do that. So what I'm going to do, for the first part, I'm going to take, and I'll do that, I'll highlight that in green. I'm going to take this first number and write it down here. And I'm going to multiply that by the determinant that I get when I cross out this column and this row. So I'm just looking at the determinant of this 2x2 matrix. So I'm going to multiply 1 by the determinant of 1, 2, 1, 3. So that's my first step. So let me underline that in green. And finding the determinant of a 2x2 matrix, we all know how to do that. The second step is where most people make their mistake. For the second part, I'm going to put a minus sign here. So the middle one is always negative when we do it this way. Now I'm going to take this number. And I'm going to multiply that by the determinant that I get when I cross out this row and this column. So I'm crossing out the top row every time. So now I'm left with the determinant. I'm crossing out this column. 3, 2, negative 1, 3. So I have this number, this number, this number, and this number. So I'm crossing out. I'm crossing out this column for this one. So this is an easy determinant to find. And now I'm going to take this number. And multiply it by the determinant that's left when I cross out the top row and this column. So I end up with the determinant 3, 1, negative 1, 1. So that's that one, and that's that one. So my determinant here, I get 1. The determinant of this matrix is 3 minus 2, which is times 1. Minus a negative is positive, so I get 2 times the determinant here is 9 minus negative 2, or 9 plus 2 is 11. Plus 3, and the determinant here is 3 minus negative 1. which is 4. So my determinant is 1 plus 22 plus 12. I get 23 plus 12 is 35. So the determinant of this matrix is 35. And that's our way we can find the determinant of a 3 by 3 matrix without plugging it into our calculator. Now, I mentioned the other day that when you're working with vectors, in my calculus class we're working with vectors, we end up doing almost every problem we do ends up finding a determinant this way. And a lot of those students have done this so much that they find this determinant in their heads. I can't do it in my head, but they do this process in their heads because we do it so often. We find this determinant of a 3 by 3 matrix this way so often that we do it in our heads. But again, the process. Take the first number right here and we multiply it by the determinant that we get when we cross out that row and that column. Our second one is always negative. We take the second number in the first row, put it here, and then we cross out the numbers in the top row and the middle column, and we write the determinant of that matrix. You just end up with a 2 by 2 determinant. And then we write down the third number and the determinant of the matrix that we get when we cross out the top row and the third column. So that's how we're going to, that's another way we can find the determinant of 3 by 3 matrix.
So it's the first one minus the second one plus the third one?
Yes. So the second one is always, we always put a minus there. So this is going to be a plus, minus, plus when we go across that top row. And usually if you make a mistake here, it's going to be forgetting this minus sign. That's, a lot of people forget that minus sign. All right, so let's look back as a way to show this. Let's look back at problem number 24 was one in our homework that I said we hadn't learned how to do. So let's look at number 24 because it has to do with finding this determinant. So any other questions on this process? We'll do it a few more times, and hopefully it'll become easier to see. All right. So problem number 24 in our homework. It said that we have a triangle with these vertices. Negative 4, 2, negative 3, 5, and negative 1, x. We don't know that vertex, that coordinate of that vertex. And it says the area of this triangle was 4 square units. And we want to find x. Well, what we talked about yesterday was that to find the area of a triangle, if we know the vertices, we form the determinant with its coordinates, and we put a 1 in the third column. And we divide that by 2, and the absolute value of that has to equal 4. 1/2 the absolute value of the determinant has to equal 4. So now we know how to do this determinant with this variable in it. So what I'm going to do is, if we take the absolute value away, absolute value just means it can be positive or negative. So I can have a plus or a minus 1/2 times this determinant. Equals 4. So I want to get rid of this plus or minus 1/2. So this determinant equals, I multiply both sides by plus or minus 2, equals plus or minus 8. Well, now I can solve this problem because I know how to find this determinant.
Wait, how'd you find
How did I find?
the
I just multiplied both sides by 2 to get rid of that 1/2. Multiplied both sides by 2. All right, so now I'm going to find this determinant. So to define this determinant, I'm going to take the -4. I'm going to look at this first row. -4 times the determinant I get when I cross out the top row and the first column. So the determinant I get when I cross that column out and that row is 5(1) x1. I'm crossing this column out and this row. My second number is always negative. I'm going to do minus, and then I'm going to take the second number here, -2, times the determinant I get when I cross out the top row and the middle column. -3, 1, -1, 1. Plus, now the third number in the first row, 1 times the determinant I get when I cross out the first row and the third column. -3, 5, -1, x. And this has to equal plus or minus 8. Well, now I get -4, this determinant. 5 times 1 is 5, minus x. -2 times this determinant, -3, minus -1, plus 1 times this determinant is -3 times x, minus -5 is plus 5. And that has to equal plus or minus 8. And now I can simplify this. So I get minus 20 plus x, -3 plus 1 is -2, times -2 is plus 4. And here I get minus 3x plus 5 for this one equals plus or minus 8. Well, now we're almost done. Minus 20 plus 4 is minus 16, plus 5 is minus 11. Minus 11, minus x plus -3x is minus 2x, and that equals plus or minus 8. And now we can split our problem into 2. So I have minus 11, I have a plus or minus here, minus 11 minus 2x equals 8, minus 11 minus 2x equals -8. And I can solve for x. I'm going to stop here. We know how to solve for x from here. But we will get 2 values for x on this problem. So that's how we would do number 24 and number 26 from the homework. To finding this value of x by finding these determinants. Any questions on how I found that determinant of that 3 by 3 matrix? Yes?
So why is it -20 plus x and not -20 plus 4x?
Oh, it should be, you're right, it should be plus 4x. I forgot to distribute my 4. So this would be 4x minus 3x, so this should just be an x. Thank you. And this should be a plus x. So if we finish up here, I'd get x equals 11 plus 8 is 19, or x equals minus 11 plus 8 is, or I'm sorry, minus 8 plus 11 is 3. So questions on how I found this 3 by 3 determinant using this method. So one of the types of problems that we're going to learn about today has to do with using this method. All right. So what we're going to talk about today is lines in a plane. How to tell if 3 points are on the same line. Now we said before that if we had 3 vertices of a triangle, if we had x1, y1, x2, y2, and x3, y3. We had 3 vertices of a triangle. We said the area, we found the area by forming this determinant. x1, y1, 1, x2, y2, 1, x3, y3, 1. Found the determinant, divided by 2, and found the absolute value. The area of that triangle, that's how we found the area of the triangle. If this area is 0, that means we don't have a triangle. Our triangle's squashed flat. So if the area is 0, that means all 3 points are on the same line. So we're saying that our triangle, and rather than having a triangle, we've squashed it flat, so all 3 points are on the same line. So this is how we can tell if 3 points make a line in the plane. We form this determinant, and if the determinant is 0, then we know that those 3 points are on a line. So what we're going to say is if we have 3 points, our same 3 points, x1, y1, x2, y2, x3, y3. If this determinant if that determinant is 0, then the 3 points are on the same line. So this is a test to decide if 3 points lie on the same line. So the type of problem that you might see using this idea, and it's related back to the idea of the area of the triangle, is the problem will give you 3 points and say, are these 3 points on the same line? So let's look at a problem like that. Are the points 0, 1, 4, 4, and 8, 7 on a line? And the problem might say collinear. Collinear just means on the same line. So our test, we're going to make the determinant 0, 1, 1, 4, 4, 1, 8, 7, 1. And we're going to see if this equals 0. So I'm going to go through the process of doing this without our calculator. I'm going to take the first number, 0 times the determinant I get when I cross out the first row and first column, 4, 1, 7, 1. Well, that's just 0, minus the second number, 1 times the determinant I get when I cross out the top row middle column, 4, 1, 8, 1, plus the third one, times 4, 4, 8, 7. The determinant I get when I cross out that row and that column. Well, this is just 0. Minus 1 times the determinant here. 4 times 1 is 4. Minus 8 is negative 4. Plus 1 times 4 times 7 is 28. Minus 4 times 8 is 32, which is minus 4. So I get a plus 4 minus 4 equals 0. So my answer would be yes. Those points are on the same line. So you could plug this into our calculator. We know how to find this determinant on our calculator, but now we also know a shortcut. Now the type of problem that you might see about collinear points, there's one type of problem you might see that we can't use our calculator for. We'll have to use this method of finding the determinant. So any questions on this problem? All right, so let's look at an example of another type of problem. We want the equation through the lines through the points 5, 2, negative 1, 0. So we know we have a way that we can find the equation of a line through 2 points that we learned in algebra. We can use the point slope formula. So we can find the slope. We could write the point slope equation. But this particular problem asks us to use determinants to do this. So we have 2 points. The method that we know with determinants needs 3 points. So we're going to say our third point is just some point x, y. Just some point. We need to go through some other point. And we're going to form our determinant. X, y, 1, 5, 2, 1, negative 1, 0, 1. And for those points, those 3 points to be on the same line, that determinant has to equal 0. So now we're going to find the determinant of the matrix and make sure it equals 0, and that's going to give us our equation. So I'm going to take my first entry here, x times the determinant I get when I cross out the first row and first column, minus, my second one is always minus, y times the determinant I get when I cross out the first row middle column. Plus the last number, 1, times the determinant I get when I cross out the first row last column. So for this, I get x times 2 times 1 minus 0, so I get 2 times x, minus y times 5 times 1 is 5, minus negative 1 is 6, plus 1 times the determinant here, 5 times 0 is 0, minus negative 2 is 2, and that has to equal 0. So my equation is 2x minus 6y plus 2 equals 0. And that would be my equation of my line. Questions on that example? All right. I'm going to stop there for today. In your book on page 596 through 598, it gives a description of using matrices to code messages. If you want to look through those sections of the book, and I'm going to give you three optional homework problems that have to do with coding messages. If you want to go through that and look at that coding messages and do those problems on a separate sheet of paper for a little bit of extra credit, I will give you a little bit of extra credit if you're willing to do that. All right, so our homework. Um, 30 through 42 even, and let me give you the other problems if you want to do those. And those are the optional.